Welcome, Team Resistance, to Program Apprentice Training. This is Jim Huffman, and today we're going to be covering some logic. We're going to improve the existing code. We're going to review basic logical operators and or not. We're going to code to implement the following sequence, and then we're going to demo with the simulator. So let's get started. All right, the first thing we want to do is open the folder, My New Robot. And we're going to go up here to the top, and we're going to look at the defining the yellow and green buttons in LED. Well, the first thing I want to note is that there's no comments, right? I like comments. So let's put some in here. First thing is, this is the hardware area. So let's type in hardware for those that might be confused as to what this area is doing. Next, what is this red button? Well, it's a button to control the red LED. So what does the red LED do then? Well, right now let's just call it, I don't know, an indicator. Let's call it the red indicator. We don't know what it's indicating yet, but indicator. So, nice, simple, at least something. Let somebody else know what you're doing. Let's copy the inputs first. Control C, Control V, V, right? Nice shortcut. This is the yellow one. This is the green button. All right. Now let's copy the red one. Control C, Control V, V, and we'll make this one the yellow and make this one the green. All right, so now we've got our 3 buttons and our 3 green LEDs. So let's scroll on down to some code. I hope everybody noticed that this is really poor programming, and that you might have come up with some other ideas. So first thing, comments. What is this code supposed to do? This interlocks the red button to the red LED. So, tell you what, let's leave this for the time being as is, because we're going to create an example of the yellow, but let's see if we can improve it. So again, this interlocks. This time we're going to do the yellow to the yellow LED. Tell you what, let's just get rid of that, because we know it. So what do we want to look at first? Well, the red button get returns true false. And here we are comparing true false to true and true false to a false. And the if statement's looking for a true false. Doesn't make a whole lot of sense. Why don't we just go ahead and use those values? So let's get rid of this first. Right? We don't need it. You might want to leave it if there's something confusing about the parameter that you're looking at. I don't know what it would be if it's returning true, false. But you might want to leave it just to clarify things. Here we don't need it. We're getting rid of it. Next thing is, let's look at the fact that, well, we're reading the red button one time and setting it to the true value. Then we're reading it a second time to set it to a false value. Doesn't make a whole lot of sense. There's a much simpler way to go about this if we use an if-else, because we're saying if the value is true, then we want to turn on the red LED. If it's false, else, right? Just the opposite. We don't need to check it. We know if it's not on, then we want it to be off. All right? So that's a little bit better. A little bit better code. A little cleaner. You know, turning it on, this interlocks the yellow button to the LED. Great. Well, let's copy it one more time. Let's copy, I'll tell you what, let's copy this part. It's a little bit easier. Control C, come down here. Come on, come on. Control V, interlock. Now we're interlocking the green button to the LED. So, oh, almost missed it. Yellow button to the yellow LED. Right? And here we're doing the green button to the green LED. But let's take a look at this. We've already said that the green button returns true, false. The set command is looking for true, false. Why don't we just use the return value from the green get statement, green button, to drive the set command for the green LED. So what we're saying is set the green LED to whatever the value returned by the get command for the green button. Much cleaner, much nicer. I like that. I like it a lot. Very clean, very nice. Any three of these, there's a couple other ways we could have done this, but this is a nice, clean application. All right. So the first thing we want to do, if we're sure we've got everything set to green, green, yellow, yellow, red, red, red. Oh, that's good. Yeah, let's go ahead and save it. Control S to save. Let's go up here and simulate with the desktop. We're compiling the code. There we are. Come on, you can do it. Doesn't take long at all, right? First time out always takes a little bit longer. And we resolve dependencies, great. Wow, that took a while. All right. Now we're going to go ahead and simulate. All right. Uh-oh. Uh-oh, where'd my desktop go? Where'd my simulator go? Robots should not quit, but yours did. I think that's FRC's way of telling us, nope, we've done something wrong. Well, up here you will see that there are some other notes, some other stuff that came out up on the console. And one of them is talking about my digital inputs. Resource, let me get it right there. Resource already allocated. My resource is already allocated. What's that tell you? Yeah, I forgot to change the allocation, my channel numbers. So let's come in here and change that to 1. Come down, change that to 2. Skip 3, there's 4. Make that one 5. Make that one 6. And let's try this again. Control S to save it. And then simulate on the desktop. Should go a little bit quicker this time. There it is. Build successful. We're running. There's our house simulator. And our desktop stayed this time. All right, so notice I've got red has been defined. I just want to show you this. If I right click, I can edit the name. In this case, this is the yellow button. All right. This is the green button. And the yellow LED. I'm hoping they fix this, or not fix it, but improve it. With pulling these names over. I'm sure they will. This is our first pass on a simulator. All right. So now we've named them so we recognize what they are and what they do. Let's come over here and click on Teleop and just check it out. Everything's high. Great. If we take the red and turn it low, it went low. Yellow goes low, the LED turns off. Green goes low, and the green LED turns off. So, good deal. Let's go ahead and close that, and we'll go on and take a look at the next item. All right, so we're going to take a look at the logical operators now. If you've been following along in Blue Pelican Java or working with it, lesson 8 on page 37. Page 37 starts the Boolean type and Boolean operators. Boolean being logical. Talks about that, but what I wanted to go down is skip over that. You all should have looked at it, read through it. Here's the AND statement. A and B must be true, right? True, true, for the return to be true. If it's anything else, if any of them are false, it returns false. For ORing, right? Both of them must, or any of them can be true for it to return a true. If they are both false, it returns a false. Right? Pretty basic stuff. I hope you've picked up on the logical control, logical operators. Not just does it. It inverts it. So if it's true, it turns it to false. If it's false, it turns it to true. That's all we're talking about. Nothing fancy here. So just wanted to make a note though. This isn't the same and or as a bitwise. We'll talk about that a little bit later. This is just anding and oring of logic, of Boolean parameters. So just want to keep that straight in your mind. A little bit later we'll cover it. So let's move on. Okay, we've reviewed the first two items, and it's taken a little longer than I estimated. So no one should be subjected to me coding for 30 minutes. So we're going to go ahead and take a break and let you review and absorb some of this information. Then we're going to return and code a new sequencer and demo it. So see you soon.